Hello everyone, welcome. Today we are looking at section 3.5. We are solving quadratic equations. Solving a quadratic equation means finding the x-intercept or the roots, okay? So that's what it means to solve. There's a whole bunch of ways that we can do it. We've already seen a few of them in class. We can factor, we can graph, or we can use our quadratic formula. So you should have seen most of these in grade 10. We've seen a couple of them already this year, but these are how we solve for a quadratic. Okay, before we actually start, the first method I want to look at is factoring. For factoring, we have to remember something called a zero product principle, and that's this guy right here. Okay, what in the world is a zero product principle? If you have any two items and they are being multiplied together, in order for the answer to be zero, either A is going to be 0 or B is going to be 0. Okay, so we're going to need this idea when we are solving for quadratics. Okay, sorry, back to the zero product principle. We're going to need this when we are trying to solve. So if I wanted to solve one of these by factoring, if I look at this equation, I need to find out what I plug in for x in order for this thing to equal 0. So the first thing I'm going to do is factor this. Actually, I might be able to do it here. It's okay. All right, so I have x squared plus 7x plus 10. And this, oops, equals 0. Okay, so I need to find two factors of 10, okay, two numbers that multiply to 10 that add up to 7, okay? I don't care how you do it. Write down all your factors, okay? The better you are with your times tables, the easier this becomes. So I can't add 1 and 10 to get 7. I can add 2 and 5 together to get 7, so 2 and 5 are my factors, okay? So these two are the two that I'm going to look at. So I'm going to break up my brackets, right? Because factoring means adding brackets. And I'm still going to keep my equals 0. So in here, since my factors were 2 and 5, okay, I'm going to open up with the x's. There's my 2, there's my 5. Now let's think about our signs. Positive 2 and positive 5 would multiply to 10, and positive 2 and positive 5 added to give me positive 7. So these are both positive values. Okay, this is where your zero product principle comes in. Either this bracket is going to be 0 or this bracket has to be 0 in order for this statement to be true, right? Because if this whole thing equals 0 and this bracket is being multiplied by this bracket, either x plus 2 is 0 or x plus 5 is 0. So when I go to solve, okay, and I know this is a simple example and you've seen these last year, but you can use this method for even more challenging ones. So either x plus 2 equals 0 or x plus 5 equals 0. Okay, so I set each one of these brackets equal to 0 and I can solve for x in both cases. If I need to isolate for x here, I've got to take this plus 2 and bring it onto the other side. The opposite of adding is subtracting, so when you bring it over, it would be a minus 2. And over here, I have x plus 5. When I bring the plus 5 onto the other side, it would be x equals minus 5. Whoa, minus 5, minus 5. Okay, so these are your two factors, okay? So this would be the solutions. Sorry, these two would be the solution to your quadratic your quadratic equation. Okay. All right. So this is using factoring. Now this is a simple example where the values in here, yeah, you can just see that the signs are opposite. That's not always going to be that simple if there's coefficients in front of your x. So try and use this idea right here with setting each bracket equal to 0. Okay. Let's look at super fast. Let's just look at this one over here. Okay, 4x squared minus 16 equals 0. if I factor right away, I'm going to have a number in front of my variables. So I kind of want a common factor first. You should realize that you can factor out a 4. You would be left with x squared minus 4. And this just gives us a lot of easier numbers to work with, and it reduces a lot of the work we'll have to do afterwards. Once you've got it common factored, look inside your brackets. You should realize that this is a difference of squares. So this would be x plus 4 and x minus 4. Okay, and that whole equation, or this expression on this side, should equal 0. So there's no way 4 can be 0. So either x plus 4 is equal to 0 or x minus 4 is equal to 0. So again, take a look at everything with a bracket. Okay, x plus 4 equals 0. Or x minus 4 equals 0. Okay. In order to get the x by itself, take the positive 4 and bring it onto the other side. When you bring it over, in this case, you would end up with x equals negative 4. When you solve this bracket over here, the x minus 4, when you bring the negative 4 onto the other side, it would become a positive 4. Okay, so these down here are your two solutions to this quadratic formula, or this quadratic equation. Okay, all right, so that is our first method using factoring. The second method we're going to look at is our quadratic formula, and then we will look at graphing. And there it is, the big reveal, your good old quadratic formula. Okay, x equals negative b plus or minus b squared minus 4ac over 2a. You need to have this memorized. I don't care if you're in grade 10, 11, 12. This is something that is a must for anyone in mathematics. So given any quadratic, ax squared plus bx plus c equals 0, you can solve this by using this formula. Okay, so for example, if I have 2x squared minus 9x plus 13 equals 0, let's look at this example. This is way too complicated to try and factor. Factoring is the easier of the methods. If factoring you can't get right away, leave it. Stop wasting more than like a minute on trying to factor something. If the factoring doesn't work, pop over to your quadratic formula. So this is my quadratic. Okay. My a value is the number in front of the x squared. So my a value is 2. My b value is the number in front of just the x term. Look at the signs to make sure your values are correct. My b value is actually negative 9 here. So b equals, equals negative 9. Okay. And then my c value is 13. Okay. So c equals 13. Okay. And now we're going to plug all of this in. We're going to plug these values into our quadratic equation and try and solve. Now, we just did an entire unit on radicals. You should be keeping your answers in radical form up to the very end. I do not want to see decimals partway through your work. If it's up to me, I would absolutely leave everything in radicals. Your textbook does turn them into decimals. If you're doing work for me, keep it as a simplified radical form and then the decimal in the very last step. Okay. All right, so let's look at this one. So a is 2, b is negative 9, c is 13. So the first thing I'm going to do is, I like copying my equation first. I'm just not going to here because it's difficult to write this way, but I'm going to take my values and plug them in. So negative b, that's like having negative and then negative 9. I'm actually going to take the time to write it out. Okay. And this is, I'm just trying to stop you from making silly mistakes or silly errors because I don't want you to mess up those signs. Okay, now we are going to plus or minus the square root of b squared. So negative 9 squared minus 4 times 2 times 13. Whoops. Okay, and this is all over 2a, and my a value is 2. Okay. All right. So A negative times a negative is positive, so this is going to give us positive 9. And then we are going to plus or minus the square root of this guy. Negative 9 squared is negative 9 times negative 9, so we're looking at 81. And then I'm going to minus 4ac. Okay, 4ac, 13 times 4, 26 is 52. 52 times 2 is 104. Okay, and this is all over 4. Oh, this didn't go well. It's all right. So 9 plus or minus, and then you're going to take 81 minus 104. And if you plug this in on your calculators, oh no, you got a negative number under the root sign. So we get negative 23. It's okay. We got to learn how to deal with these. Negative 23. Now, if we were working in the imaginary number system, everything would be fine, but we're not. We're working in a rational number system, so we can't have negatives under the root sign. So in a case like this, unfortunately, we have to stop here. There is no solution. So you would finish off by writing a sentence, there is no solution to the system. If this was a positive value, you would just continue off 9 plus whatever that answer is divided by 4, and then do it again, 9 minus that answer divided by 4. But let's continue looking at this one here, okay? I'm going to take this equation, and I want to see what happens if we graph it, okay? And this will be our third method for graphing, okay? So let's plug that in. Where's Desmos? There it is. Oops, 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 oops. I'm sorry, I didn't want to do that there. No, bad computers. There we go. So I'm going to take this equation, 2x squared minus 9x plus 13 equals, oh, plus 13 equals, oh, never mind. That's all we need for this one. Okay. And what you can see is that we do end up with this beautiful parabola, but this parabola does not cross our x-axis. A solution to a quadratic equation are its x-intercepts. So if there are no x-intercepts, if it doesn't cross the x-axis, there isn't a solution. You can't solve this. So the reason we ended up with a negative under the root sign is because there is no solution. There are no x-intercepts. And when you look at the graph, it doesn't cross the x-axis, so there are no solutions or no roots or no x-intercepts to this equation. Okay. Okay, let's just do a quick word problem. Before we get to that, I want you to look at these 5 examples and just quickly go through as to why you think, or which method you should use and why. So if we look at this first one, just taking a quick glance at it, there's no a value. It should be pretty simple to factor. Right away, I know that 9 times 3 gives me 27. I should be able to add them to get to -6, -9, and +3. Yep, so I would factor that one. This one over here, at a quick glance, I would love to say it's a perfect square trinomial, but if I play around a little with it, it's not. Okay, because remember your perfect square, I'm not singing it. So the perfect square trinomial song, take the square root of both sides, double the product, I wouldn't get 9. So this is not a perfect square. I don't want to waste my time factoring. I would use the quadratic formula. Okay, if I go to part C, I do notice that there's decimals. I would quickly try and common factor the decimal out. You probably still wouldn't get nice numbers, so I wouldn't bother factoring. I would use quadratic formula. Okay. If you happen to have a graphing technology program open, awesome. I don't tend to use the graphing a whole lot because they're not very accurate. So really, I only do the 2 methods. I do the quadratic formula or factoring. This one here, part D, factoring, super simple. I can take an 8x out of both terms and I'm good to go. This one over here, I would need to expand and rearrange first. It's written a little funny. This one I might actually graph first. And kind of check it out. Otherwise, you have to do a little bit of algebra. Okay? All right. Let's go down to an example. I've got 2 pages. I'm just going to do the this one up here. So, sorry, I am going to do, I'm going to do this one. So it's estimated that T in years from now of a population would be following this quadratic. We need to know when the population will be this number right here. Okay, so I can see this. I need to know what the time is when the population is this guy. So I'm going to take this 95865. I'm going to substitute it in. So I'm going to have 95865 equals T squared minus 24T, oh, it's not going to fit, plus 96,000. 1, 2, 3. Okay. Don't worry, I'm going to continue this on a different program in a second. So I need my equations to be equal to 0 in order for me to solve them. So I'm going to take 95865. I'm going to bring it on to the other side of the equal sign. So this is going to leave me with 0 equals T squared minus 24T. Now I'm going to have plus 9600, and I'm going to minus 95865. Okay, you should get positive 135. Okay, this is where I would like to factor. Now, if you're really good, or I'd like to solve, if you're really good with your factoring, great. This one here, just to show you, we're going to use the quadratic formula. Okay, so T squared minus 24T plus 135. This is our C value. Negative 24 is our B value, and our A value is 1. Okay, so A is 1, B is negative 24, and C is 135. Okay, got something open in Word just so we can see kind of what's going on a little bit. Okay. So we're going to go to our quadratic formula. There it is. But instead of B, I'm going to plug in negative 24. Okay. My A value is 1. I don't actually need to write a 1 because 1 times anything is just itself. And my C value is 135. Okay, and down here, 2 times 1 is going to be 2. Okay, so we can take this. Here we go. And we can start to simplify. So negative times a negative is a positive value. So this is positive 24 plus or minus. Now 24 squared is going to be a nice big number, 576. And 4 times 1 times 135 is 540. Okay. Oops, sorry, and just 2 at the bottom. Okay, let's copy this down. We're going to simplify it even further. Okay, so there's my 24, there's my plus minus. Now 576 minus 540, this is going to work out so nicely. We're going to get 36 under there, which is nice because we've got square root of 36 is 6, and we're going to put it over 2. Oops. Okay. So we know that square root of 36, let's just get rid of this whole term, 6. There we go. And so now you're going to have 2 answers, 24 plus or minus 6. So 24 plus 6 over 2 and 24 minus 6 over 2. So let's just get rid of this guy over here. We're going to come back. So x equals 24 plus 6 over 2. Or x equals 24 minus 6 over 2. Okay, so let's see, 24 plus 6 is 30. 30 divided by 2 is 15. And then 24 minus 6 is 18. 18 over 2 is 9. So our solutions, or the when you solve your quadratic, okay, your solution to your quadratic equation would be x equals 15 and x equals 9. Okay, so it says, going back to our question, it says, it is estimated that T years from now, the population is going to be this. When is the population going to be 95865? It'll be that number in 9 years and also in 15 years, because this is a quadratic that is going to, oh, that is not going to follow that direction. It is opening upwards. All right, we have a quadratic that is going to look like this. Okay, so wherever your x and your y axes would be, so at 9, it would be that 95,865, and at 15, bad math teacher, there we go. There we go. So what we're looking at is here at 9, it would be the 9,500, and here it would be the 9,500. Okay, so these are your two x-intercepts. Cool. All right. Again, there's always examples in your textbook. So take a look at another few of those, and good luck on your homework. Okay.